Assalamualaikum everyone. Welcome to today's presentation. We are come from year 3, section 3, Bachelor Degree of Electronic Engineering students. In the following demonstration, we will introduce Tesla coil. Demonstration of Tesla coil in short video format. There are 4 members of our team, which is the first one is me, Nurul Huda BINTI AHMAD RIZAN, with matrix number B02221023X, and the next is AZNEEZA FARZANA BINTI AZMI with matrix number B0222102335, and the third is SYAZANA BINTI HALIDAN with matrix numbers B0222102114, and the last one is FATIN KHAIRINA AQILAH BINTI HANAFI with matrix numbers is B0222102115. So for the list of contents, we have introduction, objective, theory, simulation, hardware, and procedure.
Okay, next, introduction. The Tesla coil, invented by Nikola Tesla in 1891, is a transformer circuit designed to produce high voltage and low voltage electricity. It consists of primary circuit and secondary circuit, which is primary contain power supply, capacitor, and spark gap, and secondary with a coil and terminal. The coil generates electrical oscillations that produce spectacular arc and spark by ionizing the air. Initially intended for wireless power transmission, the Tesla coil are now used mainly for educational demonstration, entertainment, and experiment. They remain an iconic symbol of high voltage electrical research and Tesla innovative legacy. Okay, next, objective of our project. First, to showcase the principle of electromagnetic resonance and high voltage electricity production using a Tesla coil. Second, to study the potential of wireless power transfer, a concept pioneered by Nikola Tesla. Then third, to create visible electrical discharge, arc and sparks for educational and experimental purpose. Then lastly, to analyze the working of resonant transformer circuit, including the role of primary and secondary coil.
Next, we move to the Tesla coil theory. Tesla coil is a key invention by Nikola Tesla that known for their spectacular lightning-like discharge and their role in understanding electrical. The Tesla coil is a device to produce high voltage electrical. It operates through electromagnetic principle, especially Faraday's law. Faraday says that when a magnetic field changes, it creates an electrical current. And Tesla used this idea to design a system that amplifies voltage. The Tesla coil has 2 main parts, the primary coil and the secondary coil. In the secondary coil, the wire acts like a long electrical line that electric travel through it and reflecting back and forth at its ends. These reflections create something called standing wave, or patterns where the voltage and current seems to stand still at specific spots. Resonance happens when the frequency of the electricity matches the coil natural frequency. This resonance boosts the voltage even more. The coil shapes and size, like its length, diameter, and wire spacing, influence natural frequency. The electrical properties in Tesla coils are spread out or distributed across the entire coil. These properties include 2 elements, which is inductance and capacitance. The inductance is able to store energy in magnetic field, while the capacitance is able to store electric energy between turns of the wire and against the surrounding air. This value depends on the coil wire and design. More turns means higher inductance, while the tighter spacing between turns means higher capacitance. As electricity reflects and resonates in the coil, it combines the direct and reflected waves. These waves add up, creating much higher voltage at certain points for the dramatic electrical discharge that we can see at the demonstration video later. This amplification of electricity connects to Faraday's law. The changing magnetic field in the coil induces electric currents. By controlling the design and resonance of the coil, Tesla was able to push Faraday's law to new extremes. As summarized, a Tesla coil creates high voltage using resonance. It works as a single wire system with distributed properties, and it operates based on precision.
We will be presenting both the simulation and the hardware for this project. In the circuit, we are using a 9-volt battery as the power source along with 2 times 10k ohm resistor. The switch is included to control the connection to the power supply. The circuit includes a step-down transformer with a turn ratio of 500 to 2. If you look at the image, the voltage across the transformer is quite small, which is 397 mV, which results in a high current exceeding 1 ammeter. This current exceeds the transistor maximum rating, which leads to overheat. To prevent overheating, we are adding a 20k ohm resistor to the circuit because by increasing the resistance, the current flow is reduced, which helps keep the transistor from overheating. This is the hardware of our project. We have transistor 2N222, battery 9V, transformer primary and secondary 2 times 10k ohm resistor, switch on off, and CFL board.
For procedure, step 1 is wind the coils. For primary coil, take thin copper wire and wrap it around a hollow cylindrical object like a PVC pipe about 500 until 600 turns to create the primary coil. And then for secondary coil, use thick copper wire and wrap it only 2 turns around the same cylinder near the base of the primary coil. And then step 2, prepare the circuit. Okay, so connect the 9-volt battery to the circuit via an on or off switch, and then insert the 2 and 2 transistor into the breadboard or circuit setup. Identify its pin, collector, base, and emitter, and then connect a 10k resistor between the battery's positive terminal and the transistor base pin, and then add another 10k resistor between the transistor's base pin and the primary coil. We move to step 3, which is connect the primary coil. Attach one end of the primary coil to the collector pin of the transistor, and then connect the other end of the primary coil to the battery's negative terminal. And then for step 4, which is to connect the secondary coil. So place the secondary coil in proximity to the primary coil, ensuring they share the same axis, and then leave one end of the secondary coil open unconnected to allow for electrical discharge, and then ground the other end of the secondary coil if necessary. For step 5, finalize the circuit. Double check all connections to ensure they match the diagram, and then make sure the transistor, resistor, and coils are properly aligned and secure. And then the last step is test the Tesla coil. Turn on the circuit using the switch. If built correctly, the secondary coil should produce small electrical discharge, visible sparks.